Hi everyone, I'm Anusha, product manager in the Google AI team. I work on TensorFlow Extended, which is a production scale machine learning platform. I'm very excited by the possibility of machine learning and what it can accomplish. I'm also passionate about enabling PMs to be in the forefront of defining the next generation of ML powered products and experiences. So today, I'm going to give a brief introduction to machine learning and then talk about ML product lifecycle and how a product manager can drive it. Let's first start with what machine learning is. At its core, machine learning is a new way of creating problem-solving systems. It's the science of getting computers to do something without being programmed with rules. For decades, we used to write programs by hand to provide outputs for a certain input. We gave step-by-step instructions for computers to follow. But there are certain types of problems where rule-based systems, such as providing step-by-step instructions, aren't effective. So, take a problem like filtering spam email out of inboxes. We can do it by giving a computer a set of rules to help it parse which emails were spam. This might be by filtering certain keywords like save now, or if the email contains certain text, mark that as spam. Even as we are talking through this, you are able to realize how limited and how ineffective this approach can become. Not all spam is the same. It would be impossible for us to develop rules to guess at the contents of all different spam emails you could receive. And sometimes this approach can filter out important messages unintentionally marked as spam. And what's more, rule-based systems don't always account for the messiness of real world. Take another problem beyond the world of spam. Let's say we are trying to teach a computer to recognize an image of a cat or a dog. You can try to add rules to recognize cats by saying that, let's say if this image contains whiskers, long tails, and fur, but when you have ambiguous photos as the one shown here, it's not always easy for the computer to tell what's in the image. And as you might have rightly guessed by now, this is not a cat, though all the rules that we talked about kind of indicates that this could be a cat. This is an image of a puppy. So the breakthrough with machine learning is teaching computers to learn without having to program them with rules. We can do this by showing a system lots and lots of examples, and it starts to learn from them. We call this process as training. In our cat example, we feed the system lots of labeled pictures of cats and dogs. It looks at patterns in pixels and starts to guess which is which. Now let's try to map this to how we as human beings actually learned to recognize cats and dogs. You would have started with an image in a textbook somewhere, learning something as a cat or a dog. And then over time, you would have looked at lots of different types of cats and dogs during the course of your time in your life. So we have been trained on so many data that when it comes to ambiguous photo as the one I showed before, we are able to easily point out that this is an image of a puppy, not a cat. So the same thing is applicable to a computer system. Over time, with exposure to a lot of training data, the system becomes smarter and better at completing certain tasks. We then test it to see how well it's been trained. Ultimately, a system like this can start recognizing which animal is which in a photo, even like instances like this one, where it's quite ambiguous and it's not easy to tell. But we've talked a lot about cats and dogs. It's not just recognizing cats and dogs. What's really amazing about machine learning is that it has all sorts of useful applications. But there are four things in particular where ML systems are quite good at. We've made great strides in advancements in the recent years as well. Classification, prediction, understanding, and generation. Let's look at examples in each of them. Let's take classification. Machine learning can help us predict a category based on the data it's been trained on. As we've just seen, ML systems are good at helping us answer questions like, is this image a cat or a dog? Classification is an area where ML systems are quite good at. You can classify different types of plants, for instance. You can classify a few other things based on like the data that you have. The second is prediction. These systems are very good at being able to predict outcomes or actions. YouTube is a great example of this. I like cooking and I watch lots of videos on YouTube about it. That's an example. So knowing that I've watched Gordon Ramsay videos of cooking the perfect pasta, the product can make a good guess at the videos that I'd like to watch next. Maybe something about making pizza. This is a very common feature that you might have used in YouTube. Watch next. Next is understanding. Machine learning is key to making computers comprehend speech and language. This makes it possible for you to talk to your phone or for it to understand you with a query like, say, okay, Google, what are the restaurants nearby? And finally, generation. Machine learning can make it possible to create new kinds of outputs. Take this example of a tool we created called as SketchRNN. SketchRNN lets you draw together with a neural network. You start with something, the system will complete the rest of your drawing. This is an area that's growing rapidly in the recent times, where machine learning has been used to create different kinds of outputs. Now, the rapid advancement in machine learning has been due to a subfield called as deep learning within machine learning, which has pretty much been causing a revolution in this space in the past few years. As you can see, the interest in deep learning has been growing rapidly since 2015 or 2016. So what's deep learning? It's a subfield in machine learning. It's modern reincarnation of artificial neural networks. Think of this as a collection of simple, trainable mathematical units organized in layers that work together to solve complex tasks. The best part about this is it can learn features from raw, heterogeneous, noisy data. You don't have to do explicit feature engineering. Now, what is feature engineering? What does that mean? It's the process of using domain knowledge of data to create features that make machine learning algorithms work. Feature learning is kind of fundamental to the application of machine learning. It's quite difficult and expensive. Let me give an example of feature engineering. Let's say your task is to classify different types of plants, and you have some data for that. And let's say you have knowledge in this space. As a botanist, you probably know how to classify different types of plants, and you want to use machine learning to automate that. So you will be able to explicitly decide like what kind of features in your data is going to be useful for the model to predict different types of plants. So combining the domain knowledge that you have and being able to explicitly engineer the features that you will be useful from the data that for the model to predict the actual outcome is kind of an example of how to think about feature learning. Now, while this is great, where you have domain knowledge, this is not going to scale or work for lots of different cases. And that's why deep learning has become quite popular, because for tasks like detecting what's in an image, you don't have to do explicit feature engineering. So here's an example of what kind of things deep neural networks can learn. Given an image, it can tell you what's in an image. Given an audio, it's able to understand what's in an audio. Given a text, it's able to translate that text to another language. And beyond just understanding what's in an image, it can also describe what's in an image, as you can see here. It describes that the image consists of a blue and yellow train, which is traveling around the tracks. This has made this whole area of ML applications quite powerful because of some of the key applications that I talked about here right now about deep neural networks. And by the way, neural networks are not new. In fact, many of the algorithms that we are using today were invented in the 80s and 90s. At that time, neural nets showed promising, interesting results for small toy problems. However, because the learning algorithms for neural nets are relatively expensive computationally, it was difficult to make neural networks work on large realistic data sets. The recent success of deep learning has largely come about because we finally have both large, interesting real-world data sets as well as enough computational power to train large, powerful models on these data sets. In fact, neural networks are now the best solution for a wide variety of problems in speech recognition, vision, and language understanding that we don't know to solve any other way. Now that we've talked and given an idea of machine learning and how subfield in machine learning called deep learning has caused rapid advancements in ML-powered applications, I'd like to touch upon a couple of ways to think about machine learning in products from a PM's perspective. There are two ways we can think about this: ML-powered features and ML-powered products. So let's first talk about what we mean by ML-powered features. This means the product is enhanced by machine learning, but the product itself can also exist independently without machine learning. Let's take the example of Smart Reply. It's an easy way to respond to emails on your phone with just one tap. With this feature, the system suggests contextually relevant responses to your incoming email, making it easier for you to respond right away. And of course, it gets better as you use it, adapting to the responses you've chosen in the past. Now, this feature makes it easy and convenient for the user to respond to emails. But as you know, emails have existed even before machine learning, even before the growth of machine learning in applications. What this feature does is augmenting the user journey and provides quite a magical experience for the user. But machine learning itself is not essential for the creation of email as a product. So I would call this as an example of ML-powered feature that enhances a product and improves the user journey, making it quite magical for the user. Let's take another example, which is Assistant. This is clearly an example of a product which was possible because of natural language understanding. ML is kind of core to this product experience, isn't it? Think of asking questions like, how is my commute to work? And it provides a personalized response to you. And this is all possible. This type of user journey is possible because of machine learning. So as a PM thinking about ML in products, it might be worthwhile for you to think about if you're going to add features that make a product awesome or build totally new products, which wasn't possible before until machine learning has had a dramatic growth. Both of them are fair game, but understanding the distinction here is quite valuable from a product mindset. Now that we have a high-level overview of what machine learning is, let's get into the life cycle of an ML-powered product or feature and talk about a product manager's role in it. ML product lifecycle roughly involves the 5 steps shown here: understanding the problem or framing the problem, defining success metrics, identifying data needed and data processing, training and evaluating the model, and finally deploying the model to production. At the outset, some of these steps seem very similar to traditional product development. But there are certain nuances to think about during ML-based product development. So let's talk about each step and how a product manager can play a role in this. The first one is problems framing. Even in the world of machine learning, users come first. Understanding users and their pain point is quite important. While thinking of solutions, one should consider the intersection of user pain points with ML strengths. Think about questions like, first of all, is ML really needed for this problem? Is this a good problem to be solved by ML? And sometimes the answer might be no. So it's totally okay to pivot if ML is not a good solution for the problem. And if you think that there are other ways the problem can be solved, even without machine learning, it's totally fine. There are certain areas where ML is quite good at: personalization, natural language understanding, automation of repetitive, boring tasks. So for some of these areas, ML might be quite well suited. There are also other areas where ML might not be very well suited. Areas that require a lot of explainability and transparency around how the decision was made. Areas which require a lot of data, because machine learning is obviously driven by data. Areas where predictability is preferred and where cost of errors is quite high. So it's important to understand if your problem or if your user's problem can be solved by machine learning. Now, once you identify a good intersection of problem and the solution based on machine learning, it's important to consider how the user experience will change. For example, is this new ML-powered experience going to interfere with users' habituation or muscle memory? Are there ways where you can actually lessen that? Let's take the example of, let's say we are building a next generation car. You wouldn't want to probably switch the position of brakes with accelerator, however advanced or convenient a new car is, because the implications of that could be quite catastrophic. The user is quite used to the position of brakes and accelerator, and switching that would not be a good experience and can lead to unwanted confusion for the user and catastrophic consequences. So once you make sure that you don't interfere with users' habituation or muscle memory, think about which aspects of user journey that you can enhance. Think about like automation versus augmentation of user journey. Some tasks like automation, probably people would love for AI to handle. They would totally want AI to automate it. But there are many activities that people want to do by themselves. In those latter cases, AI can help them perform the same tasks, but faster or more efficiently, and sometimes even more creatively. So as a PM, you have this huge opportunity to think about like which aspects of user journey you're going to automate versus augment, and what kind of creative solutions you can provide to help build that relationship and trust between user and the ML system. The next step is defining success. Defining success metrics is core to building any product, and as PMs, we all would be focusing on this for defining any type of product for that matter. In the case of ML-powered products, it's crucial to kind of decide what you are really optimizing for. Let's say you're trying to provide recommendation for products as a retailer. Let's take that example. How do you know that your user is satisfied with the recommendations? In an ideal world, you should be able to ask the user. Since you can do that for every user, you want to be able to find strong signals if the user liked it. One obvious signal would be to predict if they will click on the product that's been recommended. A better signal would be to predict if they will buy the product. An even stronger signal would be to see if they will buy the product again or if they will keep the product without returning it. So understanding what you are really optimizing for from a product or from a business standpoint helps flow that to actually the model and what it's going to predict. So it's important to decide what you really want to optimize for. Once you do that, it's also kind of important to decide what are the core metrics that are needed to be there for the feature launch or for the product launch. What's kind of the threshold to decide when you will turn a feature on for all users? Think of trade-offs that you will have to encounter when you have to make this call. And as PMs, we always have these trade-offs to think about. But in the case of ML-powered products, you need to think about metrics which are pertaining to machine learning, like precision or recall. Let's take an example with the same retail example for precision and recall. If a model was optimized for precision, it wouldn't recommend every single product that the user might buy, but it would be highly confident in the products it recommended. So users will see fewer suggestions overall, but good recommendations that they are most likely going to buy. If the model is more optimized for recall, the model will recommend every product the user might be interested, including other products the user might not choose. But the user will have more suggestions. So this again ties back to the core business value proposition or the product's value proposition and what kind of experience you want to provide to the user that can help you decide how to decide the threshold for the launch. Thinking early on about this, getting in buy-in from both leadership as well as your team, your eng partners or other partners that you work with, and being able to articulate the value proposition of the ML feature is going to be quite important. The third and most important step is handling data. I would say ML is mimicry more than magic. Why mimicry? Good data equals good model. If you have the right data, you learn the right lessons, and you can build the right model. Data kind of trumps all in the world of machine learning. It's true that updating your learning algorithm or model or architecture will let you learn different types of patterns. But if your data is bad, you will end up building functions that fit the wrong thing. The quality and size of the data matters much more than which shiny algorithm you use. Faulty data may cause your model to learn the wrong patterns, regardless of whatever modeling techniques you try. So, as a PM, how do you drive this process? Understand user needs and translate that to data needs. So you know that this is the user's problem that you're trying to solve. Try to map it to what data is needed in order to build the specific ML solution. And it doesn't stop there. As a PM, you have to think about fairness, privacy, security, and other aspects of like collecting and making that data available for model training. So think about aspects of sourcing data responsibly. And a PM can actually lead the team in helping building this culture of sourcing data responsibly. Think of ways to collect good quality as well as complete data for the problem you're trying to solve. Sometimes it's kind of if you don't have enough data for the problem type you're working on, you could think of ways like gamification to make it fun and easy for users to provide data. You can think about crowdsourcing or working with human labelers to get good quality label data. So it's important to figure out ways to source data in a responsible manner, while at the same time accounting for aspects like privacy, security, fairness. Now that you have collected the data, it's time to actually come to the meat of what you are doing in machine learning, which is training the model. This phase involves training the model and evaluating it. As you can observe, you need to go through several important steps like defining the problem, success metrics, making sure your user experience is good, getting the data and processing it before you can get to the heart of machine learning, which is training the model. This is something you need to be aware of from a practical standpoint, and this is how most of the practical steps would look like. As a PM, You can provide users perspective into this step as you work with your engineers or data scientists who train the model. You can help interpret the ML output to ensure that it's aligned with the product goals and user needs. You can help the team think about aspects like what challenges will we encounter if it's not possible to know why the model predicted something? Is ML output interpretability important for this product? There are certain cases where it's very important to know why a certain decision was made for a product. It could be for legal or for other privacy or security reasons. So thinking about setting the expectations on how much the user trusts the system's prediction and how that experience is going to look like is going to be quite important. And this is also a phase where you can work closely with your team and think about various edge case scenarios that you can test with. You can do user surveys early on to catch unexpected responses to the product. You might be super excited by like an ML solution that you've provided to a long-standing nagging user pain point, but if you put it in front of users, you might uncover certain behaviors or aspects that you wouldn't have even visualized or envisioned in the first place. So this is kind of the phase where you can work closely with the team to start doing some early testing and make sure that you're able to catch all these edge case scenarios and user feedback to the product. And let's say once you've done with your model training and you've done your initial user testing, everything looks good. Now is actually the fun phase of taking that and launching that, putting that to production. Many of them might be surprised to hear that production ML is actually 1% inspiration and 99% plumbing. You might wonder why. Because the plumbing code that you have to write to put models to production is much bigger than the model code itself. Often, model code constitutes about 5% of the total code that you write for an ML system. So deploying a model to production is not a one-time affair of deploying and being done with it. You need to keep monitoring for data drift, changes in data trends, training serving skew detection, and a lot of other factors when the model is out there actually serving predictions for your product. Being aware of these challenges of deploying models at production scale and the efforts that go into it will help you plan launch timelines accordingly and work with your DevOps and your engineering team to ensure that you have a smooth rollout or launch of your product. Now, while your model is actually starting to serve predictions and you have a feature that's launched, failures and errors are something that you cannot avoid. Errors can be due to misclassified labels, missing data, unexpected inputs, system limitations, and various other factors. You need to gracefully handle errors and failures by giving the user a path forward. Think about aspects like if the failure state is actually acceptable for the user. For example, we talked about the recommendations of a product from a retailer site. A recommendation system that's useful about 60% of the time could be seen as failure or success, depending on the user and the purpose of the system. So this again ties back to the success metrics that we talked about in like ensuring that you're aligned with both the user as well as within your team on what success looks like. Now, you should also think about how to identify error sources because errors can come from many places. They are typically harder to identify and they can appear to both user as well as the system engineers in non-intuitive ways. So having like a good way to keep track of crashes or having logs to better understand user behavior on why it crashed, all of that would be helpful. And also once an error is encountered, it's not about like dropping user right there. It's about creating a path for the user to take action in response to the errors they encountered. Because this helps build trust between user and the ML or AI system and helps in building an overall experience for the user. So with that, we come to the end of ML product lifecycle. Thank you to everyone who's listening to this video, and I hope this was helpful in understanding some of the aspects to consider while building ML-powered products. Thank you.